Hey, it's me. I see you have not subscribed. Please subscribe, like, and share to get more exciting videos. Stars, the big hot gas burning balls of fire. But how do they form? How do they work? And does a black hole form from thin air? Wait, there is no thin air in space. Thin vacuum? No. Stay tuned because today we are gonna see stars simplified. First of all, look at this diagram. This is the Hertzsprung-Russell or the HR diagram for short. This diagram classifies the stars according to their temperature and luminosity. Let's clear one thing up. The graph shows the stars according to luminosity, meaning how much light or heat energy it gives out, and temperature, how cold or hot a thing here the star is. The bigger the star is, the more heat energy or luminosity and less temperature it gives. And the hotter the star is, bluer it is, and more cooler, the more redder. The stars are classified according to temperature and luminosity. Most stars fall in a group called the main sequence. But there is also the group of supergiants and giants and white dwarfs and red dwarfs and blue dwarfs. These stars start from hot giant blue stars to small red dim stars. The stars fuse hydrogen to form helium, which releases energy, which then converts to light. But a star like the sun can't fuse this helium. It's not hot enough. So this helium collects near the core, increasing the density. This increased density increases the heat, and increased heat expands the gases. Thus, the small little yellow star becomes a red giant. Ah yes, red giant. It's the time, the life of a star. Well, there are, let's say, two types of lives of stars. The smaller, low mass stars and the bigger, high mass stars have a very different life. So let's kick things with low mass stars. First of all, a star is formed as the density increases in a part of the dusty cloud in a nebula. As it collapses under its own gravity, it forms a star. Due to high temperature, like real high temperature, and immense pressure due to its size, the nuclear fusion starts at the core, converting hydrogen to helium. This happens for a very much long time, like billions of years. As it turns from a hot blue to warm yellow star, the helium collects near the core of the now yellow star. As it collects over time, the hydrogen runs out. As a star this cool, as the helium collects near the core converts to helium, and now there is helium at the core. So the hydrogen outside the helium core, the shell outside the helium core, starts to convert hydrogen into helium. The outer layers of the star expand as gases expand on heating, and soon enough the star is a red giant. But as the fusion happens, the heat to fuse the hydrogen to helium can't reach outer layers, and it just starts to cool down. Soon enough, the helium core blows off the outer layers and a planetary nebula is formed. Planetary nebula is like gases around a dead core. It's not dead yet, but it's a core just. Then a dense cold core remains, which is called a white dwarf. As it cools, the white dwarf becomes a red dwarf and eventually a black dwarf. By this point, it's considered dead. Now, to the massive high mass stars. Now these stars have a different life. They initially start off as big stars consuming hydrogen much more fast due to more pressure on the core. When these stars reach the main sequence stage, starts fusing the elements in stages, like the outermost layer fuses hydrogen, then the second last layer fuses helium, and it continues with neon, oxygen, silicon, and eventually the dense iron core. When the core becomes iron, no fusion can occur because iron is very dense. The star transitions from a red giant to rarer blue supergiants, and finally to red supergiant or even red hypergiant. After this, the iron core grows, the radiation increases, and thus the outer layers are blown off to form a planetary nebula. Soon, supernova explosion. Now, the star collapses, but it can collapse in two forms. If it's small enough, it can collapse to form a neutron star, and if it's large enough, which is 3 times the sun, it collapses to form black hole, where the neutron star eventually dies off, presumably because we still know nothing about the death of a neutron star. There is no neutron star died yet. Yeah, I don't think so, at least. About the black hole, well, they're invisible. They cannot die. They're always there. There is one in our galaxy, in the center of our galaxy. There's black dwarfs for low mass stars, and neutron stars or black holes for high mass stars mark the end for a star. Speaking of end, this brings us to the end of this video. Please like, share and subscribe. See you later.